Hello, guys. My name is Desmond, and I welcome you to my lesson for today, where we will be looking at your mathematics. So, ladies and gentlemen, as always, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say it's massively. Hey, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, please, honorable members, please, Bandla kaNkulunkulu, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So, as you can see, introduction, analytical geometry. So, very quickly, I'm going to take you through analytical geometry. So, we are just going to discuss all that you need to be aware of. Hopefully, in just one lesson, you will have a better understanding of what we are dealing with as far as analytical geometry is concerned. So I will try by all means to be as slow as possible, and at the same time, just make sure that I don't lose you. So let's see. Number one, we are very quickly just going to discuss revision. So that's where we look at the distance, midpoint, and gradient formula. I'm pretty much sure that at this stage, you are aware of those formulas. So, number two, we are also going to look at inclination of a line. Inclination of a line. This is where we will also talk about an angle of inclination. Thirdly, equation of a straight line. So, lastly, application involving quadrilateral. So, this is all that you need to be aware of. Just make sure that at all the times when you study analytical geometry, you cover all of those. So let's see. Maybe let me do this and then we move on to the next part of our lesson. So maybe let me use a red color there. So let's see. Very quickly, let's discuss the distance formula. Obviously, we do know very well that it's either examiner says the length or the distance. Mathematically, it refers to one and the same thing. So, the length or the distance, it's equal to the square root of, it's going to be x2 and you minus x1 you close squared plus y2 minus y1 close squared. So every time when they want you to calculate either the length or the distance, just remember that this is what you need. And most importantly, guys, I always say analytical geometry, it's a game of two things. Analytical geometry is a game of two things, meaning when examiner says determine the length or the distance, it means it has to be from one point to the next point. So that means you need the coordinates of, let's say, point A. You also need the coordinates of point B. And that's how you're going to take those values and substitute into that formula. So, secondly, and very quickly, let's discuss the midpoint formula. Also, I'm well aware that most of you guys might be aware of the formula, but just for our record, let's just quickly discuss that and say, with regards to the midpoint formula, this is where normally it's equals to, you are going to have the first x value that you need to plus with the second x value, and all of that needs to be divided by 2, and you do the same for calculating the y values. It has to be y1 that you plus with y2, and the whole of that you divide by 2. That's how you calculate the midpoint. Most importantly, analytical geometry is a game of two things. Again, even when we talk about the midpoint simply refers to you having a line which has 2 points. It could be point A and that could be point B. When you use the formula for calculating the midpoint, you are actually calculating the middle point. So midpoint, it has to remind you of the word middle. So that means a point which is in the middle of point A and B, by estimation, it's somewhere there. That is the middle point, which means this side is equals to that side, because this formula helps you to calculate the middle point. So that's all that you need to remember with regards to the middle point. So let's say that formula is what we use to calculate the middle point. So very quickly, let's discuss the gradient formula. Let's see, maybe let me use that. Okay, so obviously gradient may be represented by a small letter m or otherwise g for gradient. We know the formula says is change in y over change in x. When you expand that, you end up having y2 that you minus with y1 over x2 that you minus with x1. Again, you need 2 things, which obviously could be 2 points. So let's say you are having that line, which is a straight line. It has to have 2 points, where let's say point A has got the coordinates and you are having point B which has the coordinates. So can you see 2 things? Doesn't matter whether it's the distance, midpoint, or gradient. At all the times, you need 2 things. Most importantly, just remember this. Remember that on a Cartesian plane, a straight line that ends in the first quadrant and third quadrant will always have a positive gradient. And the one that ends in the second and fourth quadrant, it will always have a negative gradient. Just always remember that. So that's all that you need to remember with regards to the gradient. So I think now let's move on to the next part of our lesson for today. I will just remove all of that. I'm hoping to complete this in less than 30 minutes. So I realize we have gone for about 10 minutes. So inclination of a line. Maybe let me do this, check what I've got on my next slide. Okay, so number 1, we have already discussed. Let me do that. We have already discussed the distance formula, the midpoint, and the gradient formula. So now we are about to talk about inclination of a line. But most importantly, let's have a look at that definition there. Angle formed with the horizontal in an anti-clockwise direction. It's what we call inclination of a line. So that is actually the definition which define inclination of a line where an angle is formed, and that angle is called angle of inclination. Remember guys, I'm just indicating all that you need to be aware of as far as analytical geometry is concerned. Just make sure that you fully understand today's lesson, and when you revise on your own, go through my notes and also refer to textbook for additional notes and add on to what I'm currently having there. So just make sure that you pay full attention. So let's see. Angle formed with the horizontal in an anti-clockwise direction. If we talk about anti-clockwise direction, just always remember that there is what we call clockwise direction, but in this case we are referring to anti. So that means a clock, the direction of a clock is in that direction. Let me maybe do that and say this is a clock or a watch. Clock or a watch. The direction is in that direction, clockwise. Just remember that. So that means anything in the opposite direction is what we call anti-clockwise direction. Maybe let me refer to that first sketch over there. Let me try look for a different. So can you guys see we are having a Cartesian plane there, and then we've got that straight line forming that angle in that direction. Let me quickly undo that part. Yes, in that direction. So can you see that angle formed there? It's what we call an angle of inclination. Also, let's have a look at the second sketch there. So, can you see we've got that straight line there. Angle formed in that direction, which is an anti-clockwise direction. That angle formed, it could be written there, it could be written there, it doesn't matter. As long as we know we are talking about that line with the horizontal. That angle formed is called angle of inclination. Someone might be wondering, what exactly is the difference between the line for that first sketch and the line for that second sketch? The only difference is that you've got two lines where the other line ends in the first quadrant and the third quadrant, which means this line, it is the one that has positive gradient, whereas this one, it ends in the second quadrant, and this one ends in the fourth quadrant, which means this is that line, remember, which has a negative gradient. In addition to that, I think it's worth it for me to just indicate that where you are having a positive gradient, your angle of inclination will always be less than 90 degrees. Whereas in this case, where the gradient is negative, your angle of inclination will always be greater than 90 degrees. I just noticed this now as I was explaining. So just be careful, guys. In some calculations, you might be calculating an angle of inclination, and on your calculations, especially this one, always where the gradient is negative, you are going to find a negative angle. Just know that that negative angle is actually this angle. It is not the angle of inclination, because it's going to be a negative angle. What we know is that angle of inclination is positive. So that means this is where your teacher is going to say, the moment you get a negative angle, you are therefore going to say angle of inclination is equals to, we know that 180, you minus it with that angle that you got. And you are therefore going to get a positive angle, which is obviously greater than 90 degrees. Remember, guys, everything that I'm explaining now, it doesn't need to make perfect sense. You just need to be aware of all of those. I'm telling you, once you attend lessons where I solve the problems related to analytical geometry, that's when everything is going to start making sense. For now, in case if it feels like you are seeing what I'm explaining there, but it doesn't make sense, do not worry that much at this stage. Just be aware of all of that. So this is just a summary. That is just a summary of those two, meaning I'm just indicating that this is that horizontal and you've got a line. On that line, you've got some angles there. The first angle, maybe let's say this one. This is what we call the angle of inclination, because it is the angle that is formed with the horizontal in an anti-clockwise direction. This is where you are going to find your angle being less than 90 degrees. And remember, it has a positive gradient. So also there is that angle which is not an angle of inclination. Why? Because it is the angle in the clockwise direction. So don't get confused by that third sketch. It is just to remind you of the angles involved there. So very quickly, let's move on to number 3, which is where I'm going to explain to you how you determine equation of a straight line. Equation of a straight line. So as you can see there, we've got that formula, and there it's another formula. So when it comes to determining an equation of a straight line, remember, guys, analytical geometry, it's a game of 2 things. So that means you will need 2 points. Maybe that point there, that point there. So M represents the gradient, which means from that gradient formula, you're going to use point number 1 and point number 2 to determine the gradient of that line. Once you've determined the gradient, you can see what you now need is the C value. With regards to the C value, you are therefore going to use the coordinates of that point, or you can use the coordinates of that second point. It's up to you whether to use this or that. But for me, I always choose the coordinates that does not have too many negatives or no negatives at all, because it's easier to work it out. And also the coordinates that do not have the fractions, it's easier to work them out. Also, you can use this second formula where you've got that being the gradient and you find it in the same manner using the gradient formula. So here where it says y1, that's when you can substitute y of point A. And then here, this is where you can substitute the x of point A. Then you just make this y the subject of the formula, and you are going to have an equation in that format of y. It's equals to mx plus c. Obviously, the gradient, you would have calculated it there, and then that c, it will work it out as you simplify that after you have substituted. So it's really up to you whether you use that or you use the second formula. For me, it has always been easier to deal with that one. So now that I've indicated how you determine an equation of a straight line, very quickly, let's discuss that. Someone might have thought I forgot to explain that part. But I wanted you to be aware of an equation of a straight line. Maybe let me remove all of that. I'm hoping that I'm not moving too fast. But remember, guys, just make sure that you pay full attention. You might not need to write everything as I'm writing, because these notes are available on our online library, so you can easily access them there and practice at a later stage. So now, very quickly, let's maybe have a look at something. Let me see if I can use that color. Okay, so let's see that. Okay, let's see. Obviously, you must be having a line. Let's maybe refer to that one. You must be having a line. And that line, it obviously has a gradient, which is going to be a positive gradient. It seems like it's not clear, that color. Let me choose that one. So obviously that line is going to have a positive gradient. Examiner might say determine that angle there, and you know that angle is the angle of inclination. It's very, very much easy to calculate angle of inclination using that formula. So that formula says tan of an angle of inclination is equals to the gradient. That gradient, it is that same gradient that you use or you find using that gradient formula. And then once you have determined the gradient of that line, I'm just going to make an assumption that it's maybe let's say it is 2. Obviously it has to be a positive value, so positive 2. So that means you're going to say angle of inclination is equals to, on your calculator, second function of the gradient, which is 2. You punch that on a calculator and it gives you an acute angle which is in degrees. Acute angle meaning it's an angle which is obviously falling in the first quadrant, which is less than 90, but between 0 and 90. Yes, we call those acute angles. I hope that makes sense. So that's when you are dealing with a positive gradient. Let's now have a look at how the calculation looks like when you are dealing with a negative gradient, because it's a bit longer when you compare it with a line of a positive gradient. So just know that if the gradient is positive, it's quick and easy. So maybe let's talk about that line having a negative gradient. So let's say there, that line having a negative gradient. So an angle of inclination, it is that one there. You still use the same formula, honorable members, which is tan angle is equals to the gradient. So let's say the gradient is negative half, negative 1/2. So that means to calculate that angle of inclination, you are going to say tan of an angle of inclination is equals to negative 1/2. The angle of inclination, then you say second function of tan, negative 1/2. I'm telling you guys, an answer that you're going to get is going to be a negative answer. Let's say, for example, you punch all of that and it gives you negative 45, because it's an angle, then 45 degrees. Good people, that angle, it's not an angle of inclination, but it is actually this angle in the clockwise direction. So that means you are not done, because what we know is that an angle of inclination is positive, and also because it's for a negative gradient, angle of inclination is going to be bigger than 90. Can you see that angle? It is bigger than 90 degrees. This is where I'm saying, let's see, 180 degrees. It is obviously equals to angle of inclination when you plus it with that other angle there. Let me do that. So that is why we end up saying angle of inclination for that line having a negative gradient, where when you calculate you get a negative angle. It is equals to 180 degrees. Then you are obviously going to minus that angle that you got. So in short, you are going to say 180 degrees minus 45 degrees. You punch that on a calculator and it's going to give you a value. I think is it 135? Yes, because when you add 5, it's 140 plus 40 is 180. So that means that angle of inclination for that line having a negative gradient, it is 135 degrees. I hope that makes some sense. So that's all that you need to be aware of regarding calculations involving angle of inclination and a line of inclination. So I think I will just leave it there, and let's try to check on my last slide in terms of what we've got there. So this will be the last part of my lesson for today. Introduction to analytical geometry. So let's see how to determine straight line equation. I think I have briefly explained that to say, for you to determine an equation of a straight line, honorable members, you must be having 2 points. Sometimes you might not have 2 points, but if you don't have 2 points, you must be having 1 point and a gradient somehow. So let's always remember that. So there I've got some important information, honorable members, where I'm saying for parallel lines, the gradient of line 1 is the same or equals to the gradient of line 2. So it's more like I'm saying when you have a line which is parallel to that line, the gradient of line 1 is equals to the gradient of line 2. That's all that you need to remember regarding parallel lines. It is as easy as that, but it might be tricky in a question, which is where you need to make sure that you don't miss any of my upcoming lessons. Lastly, not lastly, but secondly, for parallel lines, when you multiply that gradient and that gradient, they will give you -1. For perpendicular lines, I meant to say. So that means when you have a line, you could be having another line there. So for these lines to be perpendicular, they form 90 degrees. So that means when you multiply the gradient of that line with the gradient of that line, you are going to get a product of -1. Always remember that. It is as easy as that. You will notice how we do calculations involving those. And lastly, for diagonal lines, let me get that. For diagonal lines, the distance of line 1 is equals to the distance of a line 2. So it was actually supposed to be 2 there. Let me quickly update it there. Yes. And also, honorable members, secondly, you need to remember that they've got equal midpoint. Maybe let me do a sketch there and say, if maybe we are having that. Yes, if maybe we are having that. What you need to remember, which is what I'm explaining there, is that from there all the way up to there, that is the diagonal line. It's equals to from there all the way up to there. So from corner to corner, you've got those lines being equal. Automatically, or obviously, as you can see, the midpoint of those lines is common. So if we are having A, B, C, and D, what I'm saying is BC is equals to AD. That's what I'm saying. And also, that midpoint there, it is common. So just know that if you know the coordinates of C and the coordinates of B, if you calculate the midpoint using B and C, that midpoint is the midpoint again of AD. So that's all that you need to remember, honorable members. I think I have discussed all that you guys needed to be aware of regarding analytical geometry. And I think this brings us to the end of our lesson for today. But let me just slide this side just to check and make sure that I have explained all that I wanted you guys to be aware of. I think I've covered everything there. So lastly, let me check there. So let's see very, very quickly. This is what we discussed. We did discuss the distance formula, the midpoint formula, and the gradient formula. And with regards to the distance, we said distance, length, same WhatsApp group. Midpoint refers to the middle point between 2 points. With regards to the gradient, we know for those type of lines, we've got positive gradients, and for this type of lines, we've got negative gradients. And we also discussed regarding parallel lines and perpendicular lines. Inclination of a line, yes, we have discussed that. Equation of a straight line, yes, we also discussed that. So this last part, application involving quadrilateral. This is where now you are going to apply all that I've discussed on exam question papers, which is why I would like to encourage you not to miss my upcoming lessons, because I'm going to use all that I discussed in this lesson to answer exam type of question papers. So I think I did discuss all that I wanted you guys to be aware of. So, ladies and gentlemen, I do thank you very much for joining. My name is Desmond, and I'm out.